Video lesson 11.1. Today we're going to talk about the distance formula. So the distance formula is something that allows us to find the distance between 2 points. But before we get into what the distance formula is, let's talk about like how it can be used and some other key points around it, like why is it important. So first thing, if you look at example 1, let's utilize this a graph here. So if I was to connect those 2 points, A and B here, all right, I want to know the distance between those two things. So traditionally on graph paper, we can kind of cheat a little bit here. I don't have to go through the entire process to determine, the distance formula, because I could actually kind of cheat by making a right triangle here, like so. And I'm going to make dotted lines there like this. And that allows us to count the boxes, because as we've discussed in class, I can't count the boxes here when they're on a diagonal. I don't have full boxes. I don't have necessarily half boxes. I just can't count one. They're not a whole. But I can count vertical and horizontal grid lines because they're perpendicular to each other. So if I count here, I got 1, 2, 3, 4, 5, 6 for this one. And 1, 2, 3, 4, 5 for that one. So now I have the distances between the horizontal and the vertical change between B. All right. So that we now can say for sure is a right triangle. And if we look at B, if I got a right triangle with 2 legs, I could find the third one using the Pythagorean theorem. So I can utilize the Pythagorean theorem. All right. I can now plug in my 2 legs, which is 6 squared and 5 squared, and that would equal my hypotenuse, which I'll just call C. And we've got, in this case, 36 plus 25 has to equal C squared. If I add those together, I get 61 is equal to C squared. And if I now want C alone, I take the square root to undo the squared portion. So the hypotenuse, aka the length of A to B, is radical 61. Right? And again, if I could simplify that radical, I would, but in this case, that's the best that I can do for that one. So that's the way we can get the distance between A and B. Now, that's wonderful. We can use it on graph paper here by counting those boxes and everything and making these, right triangles, which is helpful and great. Right. But again, it only works when dealing with actual graph paper here. So if you look at example 2, in order to do this right now, I have to go out and sketch this, right? So if I take a second, if you kind of sketch it, it should look something like this, right? Where I now have my points, 1, 5, and 3, 11, right? That would be, connect them. If I make that the hypotenuse and I can create a right triangle from there, I now would have change. Obviously, if you're sketching this, it's a little harder sometimes because there's no boxes to count, but you can utilize the y-axis difference and the x-axis difference, and that gives you the values of those segments. I could do the same thing below, like I did it above, but I'll just show you. I could do it. Let's do it in green here. I could do this change and this change. It would be the same thing and I'd still have a right triangle. So that doesn't matter, but you can see how we can still get it, but it makes it a little bit more difficult because now you're not dealing with graph paper. You're kind of sketching it and you have to do it all yourself, but we have the work. So let's actually find out the answer to this one. So the distance between the 2 points is going to be A squared plus B squared equals C squared. So I'll give you guys a chance to try and figure out what that is. If you want to pause the video to do so, go for it. But we're going to plug in the 6, we're going to plug in the 2, and we're going to determine what the hypotenuse is. So 36 plus 4 is equal to C squared. So we've got 40 is equal to C squared. Again, to undo the square part, we take the square root. And C is in fact rad 40, which I can simplify. So I can break that down into radical 4 times radical 10. Sloppy, let me try that again. Radical 4 times radical 10, and that's 2 rad 10. All right, so my distance overall between those 2 points is 2 radical 10. But let's be honest, having to sketch those out, that can sometimes get a little annoying, makes it more work. What if the points aren't super nice? What if they don't cross at nice grid points? So we need to kind of have an alternate method here. So that's where the actual distance formula comes into play. So here's the distance formula. Let's just highlight that real quick. Here's the distance formula. All right. And it does actually, in fact, come out of the Pythagorean theorem. If you look at it, it's the difference between the x values squared plus the difference between the y values squared. And the square root portion, again, when we're solving Pythagorean theorem, we take that c and we take the square root of it, right? That's the square root of all of this information. So it really is just a manipulation of the Pythagorean theorem just with respect to the coordinates themselves. So, all right, so let's take this first example. Let's not sketch it. Let's go right into the distance formula here. So, d for distance here. So d is going to equal, right, the difference in our x values and the difference in our y values. Now, who we call x1 and y1 doesn't really matter as long as you're consistent. I know most of us will call this one x1 and this one y1. And that would make this one x2 and this one y2. But again, honestly, if you switch them around, it's perfectly fine. As long as the x's and the y, like the sub numbers, are the same for each point, then you're good. So, but based on how I did it, I'm going to plug it in. So 15 minus 3 squared plus, it's going to be 7 minus 12 squared. Let's simplify that. That's going to be 12 squared plus that's going to be negative 5 squared. So we can take those. That's 144. That's going to be 25. And when we add these together, I get 169, which is the square root of that is in fact 13. Nice whole number, no radical to have to simplify. We're good to go. So that's the process for using the distance formula. All right. Again, don't have to sketch anything, don't have to graph anything or create the right triangles. I can just use the formula and plug it in and find the answer. So give you guys a second if you need to pause the video to try example B. I am going to tell you that the answer is, what's going on there? The answer is 10. So give you guys a chance to try it and see if you can get the right answer. All right, so hopefully you have gotten the answer of 10. This is what it should look like. Again, it was something that was worked out nicely as a whole number. Not all the time. A lot of times we get radicals that you may have to simplify. But again, that's just part of the process of simplifying numbers. All right, example 4. How do we utilize the distance formula to prove different things? Because that's really what we're going to do in the long run. So let's try to start looking at this. So the first question says, prove that we have an isosceles triangle. So first things first, if they don't sketch this for you, I strongly recommend that you do, because it allows you to kind of sometimes determine what to work on first to try and shorten the process here. So if I'm looking at this picture and I don't know which of these sides are equal, but again, at least a sketch will give me a fighting chance to maybe do less work. I don't want to have to find all 3 sides if I don't have to. Because in isosceles, for it to be isosceles, I only need 2 equal sides. So based on this picture, it looks to me like A and B and A and C could be equal to each other. So I'm going to start with those to determine, if those are in fact the equal sides. Now, if they end up not being, then I would go and find the 3rd side to see maybe I was wrong. But again, it gives you a fighting chance to start somewhere. So let's take the opportunity to do that now. So this first one here is AB. Let's find out what that is. So again, we're going to take the square root and we're going to do the difference between the x values and the difference between the y values. So here's A and here's B. So I'm going to do, again, the order that you do, it doesn't matter as long as you do it the same for both of them. So let's do -3 plus -9. all squared, plus, again, I started with a -3, so I'm going to have to start with 8 here for the y's. So 8 minus 0 squared. So take the square root. -3 plus -9 is going to be, I'm sorry, whoops, oh, I realized I made this a plus. This is supposed to be a minus. So I'm subtracting -9, so it really means I'm adding these together. So I get positive 6 squared plus 8 squared. So that's 36 plus 64, which is going to be the square root of 100, which is in fact 10. All right, so now let's do the same thing for AC. Hopefully we get the same answer. So AC is going to be the square root of, so now I'm dealing with A and C. Again, it doesn't matter who you start with. I'll start with A again. So -3 minus 5 squared plus 8 minus 2 squared. So that's going to be the square root of -3 minus 5 is -8 squared plus 6 squared. Any negative number squared is a positive, so 64 plus 36, that's the square root of 100 again, which is also 10. So we in fact now have these two answers. So both of them here, as you can see, both of them are 10. So we could say a conclusion here, right, is since AB and AC are of equal lengths, then triangle ABC is an isosceles triangle. All right, kind of wraps everything up for that information. Again, if I didn't get those two, I would have checked BC, but again, in order for it to be isosceles, I only need 2, so I can stop here. All right, C. C is asking for it to show that it is also a right triangle. Well, at the moment, we don't really have, we only have one option here, and that is to show that the Pythagorean theorem is true. If it's true, then it must be a right triangle. So there are other means to finding or proving that I have right triangles. We'll talk about that a little bit later on. But for right now, let's utilize the Pythagorean theorem. So I am actually going to have to find BC. So let's figure out what that is right now. So BC, let's just scroll back up here for a second, find, so I can see the numbers here. So B and C, so square root of, we'll go -9 minus 5 squared plus 0 minus 2 squared. So I'm going to get here, it's -9 minus that, so it's -14. What's going on there? All right, so let's fix that. So -9 minus 5 squared, and we had 0 minus 2 all squared, and that's going to be -14 squared plus -2 squared. So when we square that, we are going to get 14 squared is 196. -2 squared is going to be 4. So square root of 200. From there. Now, I could simplify that, but we are going to plug this into the Pythagorean theorem, so I'm not worried about it being simplified at this time, but by all means, you're welcome to do so if you want. But we are ultimately doing this because we want to know, is this a right triangle, aka is the Pythagorean theorem here true? So let's plug in our information here. So our legs were 10 squared, plus the other leg was 10 squared, and we are saying that this one is the hypotenuse, which in this case is radical 200, and we're going to square that. So let's simplify everything. 10 squared is 100, plus another 10 squared, which is another 100. Square root of something squared, they cancel. So I just have 200. So 200 does equal 200. Therefore, it is correct. So since the Pythagorean theorem is true, then triangle ABC is also a right triangle. All right, and we could conclude that obviously if it's an isosceles and it's right, we can just call it a right isosceles triangle. All right, last but not least, example 15. So this one says show that you have a quadrilateral. This is another type of proof question that we will be dealing with down the line. So right now we can only do this using distance formula. So we kind of limited, but I'm going to show you as we go through the unit we have, and next unit we have alternate options for this. But just for this practice of using the distance formula, we're proving that ABCD is in fact a parallelogram. So the hint that I gave is that you want to prove the properties of a parallelogram are true. Now there are a lot of properties. For right now, because we're only got the distance formula, the one that we would utilize the most or the most effectively with the distance formula solely is that the opposite sides of a parallelogram are congruent. So I ultimately want to show that A, B, and CD are congruent, and I also want to show that BC and AD are congruent. So I'll let you guys pause the video, try to find the distances for all four sides. And we want to conclude, hopefully, that these two are equal and these two are equal. This way we can say that it is, in fact, a parallelogram, right? If they don't end up all working out to be the same, then perhaps it's not. But let's find out. So pause the video, take a moment, find all four of those sides. All right, so now that you've had a chance to find all four sides, let's see if it worked out. So I have here AB and CD. What's going on? AB and CD. All right, that's the work for those. They both came out to be radical 13. And I've got BC and AD, which have also been worked out. They end up being radical 17 each. So the key pieces of information for us right now is that we've got these two are the same, right? And we got these two things that are the same. Therefore, we now have enough information to say that it is in fact a parallelogram. So again, when you're doing these types of proofs, you always want to conclude with some type of a sentence or something that kind of sums up all of the work that you've done. So AB is congruent to CD, and BC is congruent to AD because their distances are the same. Therefore, opposite sides of quadrilateral ABCD are congruent, making it, I don't know what's going on with my pen here, making it, let's try it again, it a parallelogram. All right. Don't know what's going on with my pen. It's starting to bang. But there we go. All right. So that's our conclusion here. So we've got, again, we showed that it's a parallelogram. We've proved it because we've shown that it's got two pairs of opposite sides that are congruent. And again, the work is there to support. And my conclusion is all of the information as I've just listed it out. All right, so that's the distance formula, and a lot of things we can do with it. Take the opportunity. I've posted some practice problems for you guys to try and continue to work with.